Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong and Shoreline. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we do have an exciting program for you ahead. First, I do have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you miss any of our discussion, or you'd like to rewatch or maybe share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, we want you to send those in to us using the Q&A tab. You can find that tab on the right side of your screen. On the right side of your screen is where you'll also find the chat tab, where we want you to get to know your fellow audience members, or maybe just let us know from where you are joining us. We do have 2 polls throughout today's program, so we do want your participation there. And if you navigate to the Handouts tab, you will find a downloadable copy of today's slides to help you follow along. So on to our program topic today. We are discussing market research, the surprising cost of on-call operations. I'm joined by Anurag Gupta, founder and CEO of Shoreline, and Ashley Stirrup, COO of Shoreline. So Anurag and Ashley, thank you both so much for joining me. I'd like to give you the floor.
Thanks so much, Cody. So my name's Anurag. I'm the founder and CEO of Shoreline. Started it about 3 years ago. Before this, I was at AWS running their analytic and database services, services like Redshift, Aurora, EMR, Glue, RDS, etc. And that's really where I learned about how important it is to keep the lights on for your services, how much it really matters to your customers, well beyond issues like performance or features. People don't care about those, about keeping the lights on, except when they go off, right? Grew those services from a few million to a few billion over my tenure there. Ashley?
Hi, thanks everyone for joining. I'm the Chief Operating Officer for Shoreline. I've been in the tech industry for over 20 years, worked in a number of developer-oriented businesses. That's how I met Anurag when I was at Talent in the data integration space. And Talent was a company that started off as a software company and pivoted to being a cloud company. Algolia is a search as a service company that provides an alternative to Elastic if you're building a great search experience, born in the cloud. And at both companies, they had strong production operations teams, and yet still had significant challenges they had to overcome. And so when I heard what Anurag and the Shoreline team were working on, I got really excited. We're excited to have you all here today. We're going to be covering 4 different topics. First, we're going to look at some of the high-level survey findings around on-call. In particular, we're going to focus on some of the challenges that came up in the survey, as well as some of the high-impact recommendations we have on how, with your existing team and your existing tech stack, you can improve on-call right away. And then we'll talk a little bit about Shoreline and what it can do to also help you in these areas. So to kick it off, we're going to have a poll, seems only fitting, with a survey on, with a webinar on surveys. And so we wanted to know why have you joined this webinar? Is it that you want to learn a little bit better about how you personally can improve on call? Are you looking for ways your company can? Are you looking for best practices? And even we had a little fun. Did you want to learn why people hate being on call? So let's take a look and see what people's answers are. And in the spirit, we want to make sure that this is a interactive session today. So definitely want to encourage you to be posting questions throughout. We'll definitely have a Q&A section at the end as well. And so it's good to see that a lot of people are here to learn about best practices from other companies. That's definitely the main focus of this webinar, as well as in particular ways in which you can improve that as well. And so a little bit about this research. Shoreline partnered with a company called Dimensional Research. They have a lot of expertise in conducting surveys, in particular in the DevOps space. In this research, we surveyed over 300 qualified individuals. They were either folks that were hands-on practitioners, engineering managers, or engineering executives who work at companies with more than 100 employees. And if you just look at some of the averages of across all the respondents, there's some pretty interesting data. The first is just that the total cost of on-call for the average company is $2.5 million. And yet, even with that significant investment, the average company was seeing 8.7 major incidents in the last year. And at the same time, 48%, almost half of the incidents they're dealing with are simple and repetitive. So a lot of whack-a-mole going on, and yet still a pretty surprising number of major incidents. And then the other thing that was surprising to me was just the number of times that things are being escalated. 55% of incidents get escalated. And when something gets escalated, the time it takes to resolve that issue triples. So that's a real lever for people if they're trying to improve MTTR, trying to reduce workloads. Reducing the number of escalations represents a big opportunity. And I think just kind of getting that view of what a snapshot of the average respondent is really helpful. So here's a little bit more background on that. So the average respondent had over 1,700 nodes that they were managing. They had 13 SREs, and then engineers available on call across support L1, L2, L3 was 30. And if you look at the total amount of time to resolve, there were 278 incidents per month for the average respondent. It was taking them over 2,000 hours to resolve those issues. And so that's how we calculated the cost on call, as we looked at the average cost of an engineer and number of incidents, the amount of time it takes to resolve those incidents per month, multiplied by 12, and that got you to the $2.5 million. With that, I'm going to turn it over to you, Anurag.
Thanks so much, Ashley. So this is, so I'll just dig in on the summary information Ashley provided. So let's first look at what customers were saying were their primary challenges with on-call. So it starts off with people saying that their infrastructure is continually becoming more complex, and that creates a burden for those of us who do production ops. And that makes sense. I mean, if you go to the cloud, you go there for agility and innovation, and things are therefore moving faster. A lot of the other elements of the software development lifecycle, like testing, configuration management, deployment, artifact generation, they're getting automated. But pity the poor guy who's dealing with on-call. They're dealing with a more complex environment, possibly multi-cloud, possibly a mix of Kubernetes and VMs, possibly microservices, and that's hard. People are finding that because that's hard, that there just isn't enough time to do automation or prevent incidents because they're playing whack-a-mole. They find that their fleets are growing faster than their personnel. And then it turns into a whole bunch of personnel issues. You can't control who's on call when an incident happens. It might be your best person. It might be someone you just hired. It's hard to hire. People leave. There are also issues with bugs and deployment mistakes and so on. So I imagine a lot of these are familiar to those of you in the audience. Love to talk more about them. Let's dig in again one step down. So one of the things when I was first starting Shoreline, people were saying, hey, I've got a bunch of VMs, on-call's hard, but I'm going to go to Kubernetes and things will become awesome. And as it turns out, Kubernetes, microservices, multi-cloud have, for most people, made their on-call experience harder and not easier. Not because those are the wrong strategies to take. They probably are the right strategies to take. It's just that now you're dealing with a more complex environment. There are a lot more things to manage in Kubernetes. There are a lot more things to manage with microservices. There are a lot more cloud environments, and they're all slightly different from each other. So that's a big challenge for people. And I think that that's a trend that's only going to continue as innovation continues on the development side. So this is the second poll to talk about what investments companies have made to uh, reduce their on-call load. Super interested to hear what you're experiencing right now and what you've done to date. We'll wait till we get sort of quorum to display active answers from the community here. It's super interesting data. I'd love to have you guys engage in the chat with the answer to the, like how exactly you've improved processes so we can learn from each other. And I see there's a question of what is the meaning of node. Node in Kubernetes is the surrounding thing for containers. So think of it as very similar to a VM. It's a unit of provisioning. Okay, so let's continue. Sorry,
Ashley? Anurag, I think it's pretty interesting how process improvement is one thing that definitely comes up a lot. Yep. Runbooks were an early leader, but are kind of dropping off. We often see people investing in runbooks, but then over time, the maintenance of those gets to be really high. So that's not surprising that something that's on people's radar, but is still a challenge for folks.
Yeah, exactly. I think and it's really difficult when you're dealing with a hot issue to deal with runbooks that might be out of date, where there are multiple ones out there, all slightly different from each other. It's unless the runbook is actually runnable itself, I think that presents a challenge for people. So moving, along. Another question people have had is, what are the biggest challenges with their incident reporting systems? And obviously what you can measure is what you manage and can improve. And so I think the biggest issue that people have is not every incident makes it into the system, and the environments are more complex. The applications are 24/7. They can't, effectively analyze incident metrics, and people hate enter these systems. When you're on call, it's hard enough just actually fixing the issue. If you also have to sit there and type up retrospectives, it's painful, right? And so I think that hopefully resonates with you guys. And again, love to continue the conversation in the Q&A or the chat as we progress. Our basic suggestion here around reporting is, this, like QA in the past, security in the past, I'm going to say this a lot, what you really need to do is create a culture around resiliency and then processes around continuous improvement. So that starts with reporting. So if you track incidents per week, and then separately high severity incidents, the number of customers affected by each incident, the number that were escalated, the number that were touched by multiple people, as well as who individually got touched an incident, because it's possible someone had a really bad week versus others. And then the services that were impacted by an incident and the services that cause impact. That gives you the information you need to be able to make improvements. And that's basically what I used to do at AWS when I was managing a few million nodes. And then the idea then is that you rank based on the area under the curve. So it's basically the duration of the incident times the breadth of impact. So something that lasted a long time but maybe didn't affect a lot of customers was very impactful to the people who were impacted. Whereas alternatively, something that maybe didn't impact a lot of customers but impacted every single one is again something well worth investing time on, right? So it's a Pareto analysis, if you will, against the notion of the overall value of improving a particular area.
Yeah, and this is something that at Shoreline we also implemented. We made sure we were getting all of our incidents into our incident management system, and it really unlocked some additional insight around where are we having the most impact on customers, where should we invest. And it's easy to overlook the fact that, oh, some of my issues are getting dealt with in Slack and some are in email, and okay, some of them are in the tool. But when you get everything into the tool, it really gives you a much richer picture of what's really going on.
Totally agree. In particular, some incidents are rare but very impactful, and so there's a tendency to have recency bias, and as opposed to frequency, and also bias towards some large-scale event as opposed to the things that are impacting your customers on an everyday basis. So I think getting the data in the system removes those biases. So let's look now at how escalations impact things. So the key point here is that escalated incidents cause 3x more time to resolution than non-escalated incidents, which kind of makes sense, I suppose. But and you can see that right here, where like a lot of issues that are not escalated are getting handled in 1 to 2 hours, whereas if you flip over to the boxed area, you can see that it suddenly becomes a very long tail, largely involving escalations. And that's another very key point, which is when we think about frequency, we tend to think about the stuff over on the left, but the stuff on the right, where things are taking forever to handle, are actually what drive the mean in time to resolve. Right? And those are also the issues that end up causing you to lose customers. Like someone will perhaps, begrudgingly be okay with something that got resolved in less than 30 minutes, but they're probably looking for another solution if it took more than a day or two, right? Because that is very impactful to them, even if it was just impacting them alone. So, the degree to which you can move, do a shift left here and have more things require less people, not only is going to save you time, but it's also going to save you people time as well, because the people who are escalated to, they're effectively always on call. So you have to think about your employee health as well.
Yeah, I thought that the data here was really interesting because when you look at it, particularly for the non-escalated incidents, it feels like, oh, well, gee, we're getting an awful lot of these incidents taken care of in less than an hour. But the tail has a huge impact on moving the average. So even though a lot of issues get resolved in less than an hour, the average for non-escalated is 3.7 hours. Versus if you look at the escalated issues, that average moves all the way over to 10.7 hours. So it's easy to kind of overlook, oh, we have a handful of incidents that take a long time, but that really skews your total MTTR.
Over 8 years at AWS, there was exactly one incident that took like roughly 5 days to resolve, and I still have nightmares about that thing. It was Dublin EBS, right when I joined. That was quite horrible. So how do we reduce escalations? So the key thing, in my view, is that you have to empower the people who are doing L1s on call, or your support team, with the ability to have a self-service tool where the incident occurs, diagnostic data is captured in the notebook, and there is very clear information on what to do when it occurs, like a basic clear recipe. I mean, it's basically runbook automation, but it needs to be available in the tool itself. Now, for runbook automation to work, it needs to run inside the tool, and it can't require SSH, because if you're a company that's got SOC 2 or other things, credentials, you're going to want to limit live system access to your on-call personnel, the people who are managing your production ops environment. But so you can't offer SSH, but you do want them not to get escalated to every time someone just needs to check what's going on in the box. The other thing to do as part of that same process is to streamline the escalation so that someone in support or someone in L1 isn't on some Slack channel with 50 participants saying, like, can someone help me with, you instead would want the routing to be baked into the escalation thing in the runbook itself. And and then you also want the runbook or the notebook to be pre-populated and be the same artifact that goes from L1 to L2, L3, so that we're all looking at the same data. And so, interrupt only the right people, shorten MTTD, and that way, it's very frustrating if you get woken up or, get interrupted for something that is irrelevant. So, at least you want to reduce that. Any thoughts there, Ashley?
Yeah, no, I was just talking to someone who is L3 here at Shoreline, and his first thing is, did you run all the basic diagnostics? And when the answer is no, and he's interrupted from an important meeting or whatever it is, super frustrating. So the more you can kind of put in place tools that reinforce it's really easy to run and go collect all these diagnostics, and you're helping people to look at those so they know who to escalate to, versus here's a problem and just throwing it over the wall, really transforms the whole experience on both sides.
Sorry, can you hear? I saw you broke up there, Ashley. You still there?
Oh, yeah, I think so. Can you hear me now?
Okay, I cannot hear you. I'm going to keep going, and hopefully things are fine. My screen is frozen.
Okay, well, I will keep going here and do a little talking while Anurag is going. So this next here is around the number of incidents that are straightforward and repetitive. And to me, one of the first things that was interesting about this, so the average is 48%, so an awful lot of issues are straightforward and repetitive. And here's Anurag.
Hey, sorry about that. Just-in-time repair.
And so, but the other thing that was interesting to me is just how widespread that is. So in some organizations, it's only 20% of their issues, but in others, it's up to 70% of their issues are, kind of straightforward, repetitive, low value. And so the more you can kind of eliminate this type of work, that frees people up to be able to work on, kind of much more strategic things, more proactive things, so you don't end up with a major incident that you could have otherwise avoided.
Yeah, and I think this is a great opportunity to improve things, because, it's no one graduated from school with a CS degree to sit on call and do the same darn silly thing day after day after day, or much less, leave a family barbecue or wake up in the middle of the night to just grow a disk. I mean, those are things that the machine should do. I mean, the machine should deal with the mundane work so that we can have people do the intellectually more complex work that they're capable of. So, but the fact, so you've got to automate repetitive incidents. The challenge is that it's fairly hard. And so, which is why we started Shoreline, because, it's basically the product I'd wished I'd had at AWS. And so, a lot of us deal with alert fatigue, which means that we don't trust the alerts that come in. So how do we generate precise alarms. So it's not something like CPU is high, which could be a good thing, could be a bad thing. I don't know. But it's, something that has precision, combining a lot of data, like CPU is high and top is telling me it's the JVM process. And the JVM process is telling me it's the system thread. And the log for the particular JVM process is telling me it's garbage collecting. Well, now I know what to do, collect traces so that engineering can remove that, that issue causing us to create a lot of garbage, and also bounce the pod so that we repair it in the moment. And so precise alarms are the key to that. The other thing that's necessary is to have high resolution data, because if you want things to happen fast, you really need high resolution data, because individual data points can be bad. I remember at AWS when we just had CloudWatch alarms that ran every 5 minutes, you had to at least get 3 data points that something was bad. So you were waiting 15 minutes just to raise an alarm. Once we moved to 1 minute things, now you could maybe raise an alarm after 5 minutes, which was a big savings for us and mattered, because within 15 minutes, someone was on Twitter saying that, like things were bad at AWS. And the worst thing environment is one where your customer knows something is wrong before you do. And another version of that is you need real-time data. The reason people SSH into their boxes is because there's super long lags out of their operations tools, and you don't want to change something unless it's really still happening, right? So precise alarms, real-time data, per second metrics. Then the next thing is we all have a whole bunch of tooling already in place, right? You don't want to rebuild all of that battle-tested, work in order to run some automation tool. So really the requirement has to be to support everything you can execute at the Linux command prompt, which is at the end of the day what you're doing right now. And that means Linux command, shell scripts, Python, calls to the AWS CLI or kube control, curl into some other application, whatever, right? But everything. You should not be limited by your tool. The next thing is that, okay, so I've got automation, but how do I bake in safety? And so that's really about having guardrails and about having circuit breakers. So limiting the number of simultaneous executions, bounding where things can run, disabling the automation after some number of consecutive failures, limiting the number of issues that can run within a unit period of time. So, and then the last thing about safety is that this is something running on your behalf. You sure as heck need to know everything it did. And so that's very important. And then finally, you need a tool that gives you the ability to go from interactive diagnosis and repair to, when you were doing interactive debugging of a new issue, to a notebook, so that you could build something so that, now that you understand what's going on, for human in the loop kind of repair linked to that alarm, where it comes up, it has all the diagnostic built in, and then you iteratively and incrementally improve your resolution of that issue. And then as you discover paths down that which are well understood and repetitively occurring, convert it to a full automation. But you need that in the same technology stack so that you leverage your investments as you move along.
Yeah. Just a couple of quick questions that have come in. One was, does escalated incident mean all incidents were not solved by the first layer of support? Yeah, that's right. Whether it's L1 or support, if they have to go to somebody else, that's considered an escalation. And then the next, it was really more of a comment here, is that, it sounds like things have not improved much over the last 35 years. And the reality is, in many ways, things have gotten harder, because as we've gone to multi-cloud and microservices and Kubernetes, it has speeded up development, but it's put more pressure on production operations. And
I would argue that things have improved overall, but it's not evenly improved, right? Like maybe I was managing 5 million instances at AWS with 50 people on call, including, whereas the average DBA is responsible for maybe 100 out in the overall field. So there's a big ratio difference there. And that largely came through automation. I mean, we would not be able to deal with that kind of stuff without automation. I mean, most people don't operate at that scale, but I do think that, Kubernetes has helped, VMs have helped. But the problem is that the scales have grown, right? It used to be you had umpteen people monitoring just one mainframe, right? Now you have one guy monitoring umpteen containers, right? And so the ratio is better, but the environment's bigger.
Yeah, that makes a lot of sense.
So the other thing I hear about from people is that they fear automation. And, in some sense, by having a human in the loop, you have a natural rate limiter on how fast you resolve stuff. But, and then they comment about how a lot of the issues that arise at, hyperscalers and so forth seem to have automation as at least one component of like a series of unfortunate events. But the fact is that, human error causes about 5 times more issues than an automation error, which is exactly why, all the hyperscalers automate, right? Because you don't get to control who's on call when an issue comes up. And particularly when it's straightforward and repetitive, you're not thinking deeply. And, it may be scarier, but it's both not just more efficient and faster, but it's also going to cause fewer errors because your code can be fixed. Your human beings come and go. So here are some statistics that really surprised me out of the survey, that on average, people were, suffered around about 9 major incidents in the last year, which is a little, one every 6 weeks. That's a lot. At AWS, if an individual customer was seeing an issue across AWS more than twice a quarter, they were at risk of leaving or considering something else, or, they were certainly escalating to their account management. And so, it seems like on average, people are just running into that across the board. Because of the long tail, the time to resolve non-escalated incidents is far longer than expected. You'd think it was an hour, maybe 2, but it's actually twice that. And escalated incidents is ridiculously long. I mean, you cannot meet customer expectations at this. I mean, most of us are providing 4 nines SLAs to our customer base, and that's a few minutes a month. It's not anything close to this. So any incident that occurs is basically intrinsically breaking SLA, which means you need us. If you want 4 nines, even 3 nines, you basically need automation. More than half of things are getting escalated. That's almost tragic. Almost half of them are straightforward and repetitive, which is equally tragic. And the one that shocked me is that the number of employees that find this work fulfilling is down at 27%. And as someone who, used to manage pretty large teams, that is a crazy number, right? If your employee satisfaction number is below like 90%, you have a pretty unhealthy organization. And, there's a lot that gets explained in this, like why it's hard to hire people, why it's hard to retain people. And, it relates exactly to how hard the work is and how, in some ways unrewarding it is, because you don't get to make your work is not getting better. So with that, let me hand off to Ashley to talk about Shoreline, unless we want to take this next question.
Sure. So it says here, strong agreement that things are more difficult, especially with the generation chasm. My son's solution for legacy, e.g., running is too simple, is to rewrite, replace the application.
I think there's truth to that, and there's also maybe a degree of optimism that I don't completely share, because you rewrite your application, you're going to have new and unique ways that it breaks, right? And you don't easily get to rewrite every single bit of your stack. Most of the companies I know that have shifted to Kubernetes still have VMs running. Most of the large companies I know still have mainframes sitting around with, after 40 years, 50 years. And, now their big problem is that, people are retired who are going to manage those environments. So rewrite makes sense, but at the same time, I think it has its own challenges, right? Because it doesn't address the need from your company selling to make things, to introduce new functionality as well, right? So.
Yeah, that's really about like, where do you want to spend your innovation budget?
That's true.
And the other piece is, if you're rewriting on Kubernetes, there's still going to be issues in Kubernetes. And so at some level, you can't escape having a certain number of incidents.
So there's another question about better detail around unhappy workers. So, someone is asking if we know who, reasons why people are unhappy or.
Yeah, I don't have that data, to hand, but I'm happy to go back and take a look at that and share it out afterwards.
Yeah, and I think this was actually the respondents themselves, and, or it may have been, but I do find that the number one thing that people, type of person people ask me for links to are people who do on-call. It's super hard to hire experienced on-call personnel right now. And, people tend to leave. We do have in the detailed survey a notion of where people leave and why they, they go. So yeah. I think if we provide that to everybody, they'll have a sense of, do they move to new positions, new companies doing the same job, new companies doing different jobs? So we have that breakdown.
Yeah. Although a few things that come up consistently is, one, can be really stressful if you're working on an outage and you make a mistake and you make it worse. Another is just the repetitive nature of so much of it. If you're doing the same thing over and over again, you wonder, why do you have to do it? And then the last is, nobody wants to get woken up in the middle of the night.
Yeah, exactly. And I very much found that to be true in my own teams at AWS, that the main factors there were, people came in, let's say, to become some expert in database technology, maybe doing query optimization. And so they were specialists in one small component. But now during their on-call shift, they have to know something about everything that could go wrong, not just in their service, but all the dependent services. And so that's pretty challenging. Then the second issue is when things repetitively break, that's super frustrating for them. When they get escalated to when somebody else could have solved the issue, that's super frustrating. And, you want your customers to be happy, but, you also want to be happy, right? And it's hard to, it's not deeply fulfilling work if you're just taking it as a shift rotation once every few months, right? And because it's not really something that you get valued for. You get valued for what you provide in innovation, right? The keeping the lights on stuff is different. There is an aspect to that where culturally you need to really show that the company cares about availability and resiliency. And, at AWS, we did a lot of that stuff. Maybe we can talk about that if people want to, continue on that topic later on.
Sounds good. And so, so far we've covered a number of things that any company can go do to improve on call. Just, getting better data, streamlining escalations, attacking the kind of the repetitive stuff. You can invest in those things without a platform. But the whole purpose of Shoreline is to kind of go to that next level of giving people a platform that allows them to have a more systematic, scalable approach to solving these problems. And so, as kind of we look at the industry, we really believe that there's this huge gap in the industry. So if you look at, the observability space, there's lots of tools like Datadog and New Relic that will help you find issues. And then there's lots of tools like a PagerDuty or an Ops Genie who will figure out who to assign that particular issue to based on who's on call and has the right skill set. But that when it comes to actually debugging issues, repairing issues, and then making sure they don't come up again in the future, there's almost no tooling. And so people are SSHing into box after box and running scripts and things like that. And so this is the area that Shoreline's attacking. And we're doing it by kind of looking at that entire end-to-end experience, whether an incident's coming in through a monitoring tool and going to your engineers, or whether it's coming in from a customer call to support. How do you streamline that whole process? And so kind of working left to right, the first piece is for the kind of most common issues, how do you automate those away? Resize a disk, for example, and do those so that nobody has to get interrupted. And then those things that do need a human interaction, give them a notebook so that you can give them that kind of step-by-step playbook that's live, runnable, capturing the diagnostic information as you go. So in the best case, those people can resolve that issue instantly in the moment with the notebook. And if they do need to then escalate, they're able to hand off the notebook that has all the diagnostic information in. And so it really shortens the time to diagnose as things get escalated to L2, L3. And then with L2 and L3, we're giving people a number of tools to get real-time per second visibility into the fleet, be able to run distributed Linux commands across the fleet, which is really helpful in identifying needle in the haystack problems. Do I have a network problem somewhere? Am I seeing latency in a particular area? Do I have server drift somewhere? Those types of things. So really giving people a platform to then go build out ways to address these kind of problems, whether they're automatically or with human in the loop. And then on top of that platform, we're giving our customers an open source library so that anytime anybody sees an issue, not only can they fix it themselves, they can share it with the community. So we don't all have to figure out, what do I do if I need to resize a disk or rotate a certificate, or if I'm seeing a DNS lag, how do I address that? And the library here really spans a pretty wide variety of things. It runs across VMs and containers, across clouds. It helps you address things that kind of fall into the toil category. What do I need to do if I have server drift or config drift? Some of them fall into addressing major outages, like, if I have a DNS issue or expiring certificates. Some are more security related. So how do I do a privileged container check? Or do I have users with root access? And some are even cost related. So identifying where I've got pods that I've over provisioned CPU and memory, I've got an opportunity to right size them. Or is my infrastructure too heavy on spot instances and not enough on reserved instances? So helping people with a variety of different ways of addressing operational issues. And so that's a quick glimpse into Shoreline. Obviously, happy to tell you more if that's something you want to talk to us more about afterwards. But now we can go ahead and turn it open to the questions. So somebody said, want to learn more about debug and repair tools. Hopefully what I just covered addressed some of that.
Let me talk a little bit about that. So let's think about why this is a hard problem. So debugging and repairing an individual box is relatively straightforward. I mean, we've all learned how to do it by this time, whether it's a database or, a load balancer or whatever, right? Or just a VM, a container, we know how to do that. The challenge is doing it at scale across an environment and making sure that things stay healthy rather than dealing with things once they become unhealthy. And so, for us, what that starts with is real-time data, whether that's resource data up to the second views into your, VMs, containers, pods, everything. And then real-time metrics, so you can run locally on the box and understand what's exactly happening right there. And then parallel distributed execution, so that you can go and run a command and say, like, for every machine sitting in US East that's part of my US East 1, that's part of my credit card application, that is maybe has CPU higher than 80%, run a top command. And it basically distributes the execution across that. If you think about it, it's very similar to what Splunk does, except it's real time, and it's lets you change your environment, not just look at it. Now, that isn't the power you'd want to put in front of every single one of your employees, but it's definitely useful for your more experienced staff. And it's the underlying technology that you would apply in a controlled way for your notebooks as well. So people can go and say, like, I can run this constrained list of, commands across this particular set of environments and address these issues, or at least diagnose. And so that's underneath the covers, the core technology that we bring to bear.
Great. I want to encourage other people to go ahead and submit their questions. We do have a few more here in the queue. So this first one, I'll read to you, Anurag. So which type of on-call model do you recommend? Centralized with an SRE team, or decentralized with the engineering teams owning each of their own services?
There are advantages to both, right? Google really talks about central SRE, yet in reality, they have a lot of stuff going on within teams. AWS talks a lot about decentralized and ownership within the service teams. Yet at AWS, there is a central team that is responsible for on-call events. So you kind of need to match both. I very much believe that if you want to drive a culture of resiliency, you have to have accountability within the team for uptime. I remember I've been working for a long time, and I remember back when we wanted to create a culture of quality, people would start off by saying, I'm going to have a quality czar. But that never worked, because what that basically did is put all of the onus on somebody who was just going to walk around with the clipboard and no one was listening to. If you want, the way we actually improved quality in our industry was by ensuring that as you checked in a piece of code, you also checked in unit tests, and those unit tests ran all the time. Sounds a lot like automation, right? And that didn't mean there wasn't a QA team. Of course there was a QA team. And but it meant that the responsibility was held by both sides. And similarly, as we went through the same process on security, people started off having a security czar. Again, didn't accomplish anything. But now there's a expectation that there are checklists as part of check-ins. There are tools that run to validate environments, and then you still have security reviews that are run by people who are experts in the area. So I think we're going to find that the same thing is true of ops.
Yeah, and I think at one point I want to build on there. What you were saying is that this having the data and having each of the service owners being held accountable to the reliability of their own service and driving that down over time. I think that it all starts there, that if you've got that ownership, it's going to change the culture. Yeah.
And, sort of my prior book point on creating a culture around resiliency, it starts with actually valuing it, right? And so at AWS, every week on Wednesday, we had a 2.5-hour meeting that was led by Charlie Bell, who ran all of our engineering, and James Hamilton, and various other people who were viewed as having a deep knowledge of how to do operations well. And we discussed all of the things that had happened over the prior week. Now, hopefully at smaller scale, you don't necessarily need to run that meeting weekly, but I think the participation matters. And there was a period of time when we used to have a large percentage of our outages were due to bad deployments. And so Andy Jassy led a meeting with all the VPs in there to, talk about the last month's worth of deployment metrics and how many, went through correctly, how many went through with failures, how many of the failures got rolled back automatically, how long, customers were impacted, how many customers were impacted. You can see all of the data we were talking about there. But it was really important that it was a meeting led by Andy Jassy. So because, it showed that the importance of that issue to him and to the company. And, because otherwise, if you just push it all the way down, it may be processed inconsistently. You can't do that.
Yeah, that's a great point. So next question is Shoreline a good way to give engineers access to production while staying SOC 2 compliant?
I think so, because the key to having SOC 2 compliance is to ensure you have clear processes that prevent people from doing things that are unexpected. And that's, it's crazy to me that when someone is writing a piece of code, it goes through code review, testing, deployment across a bunch of different environments, yet an issue happens and you just say, well, you're on call, so we just SSH into the box. Like, that's insane, right? So what I think is a lot better is if you basically consider SSH as perhaps necessary but should be avoided practice, and you count that as a demerit, and something that needs to get resolved, like you would a bug. What you want to do is ensure that you don't require SSH. You don't in Shoreline, because we have an agent and it does an outbound connection over an SSL connection over your standard port 443. And so it's to a well-known address. And so you don't need SSH. We don't need any credentials. It's basically each node is responsible for its own security based on IAM or other cloud provider credentials or queue control rights. And by default, it doesn't have any rights. And so you get to have very precise ability to control what the system can do, as well as what any individual person on the system can do through, rights management on, which actions they can run, which notebooks they can run, et cetera.
Yeah. And so in addition to what you were just saying, one of the things I've heard is some customers have come to us saying, gee, today it's only the SRE team can access production. And it's really hard for my engineers because they need the diagnostic data. And so this can be a way to give people safe, audited access to the environment, but in a controlled way.
Absolutely right. In fact, SOC 2 requires that you dramatically limit access to production environments to your SRE team. But we just finished our SOC 2 audit. That's why I can quote chapter and verse. But the problem is that now you're creating yet more repetitive, straightforward load on people who are already overburdened. So you've got to avoid it.
Yeah. All right. Next question is, will these slides be shared? Really interesting survey data. Yes, we're going to be sending out the slides. We'll also be sending out the survey as well. So just registering for that, we'll send you a link to that.
And as you can tell, we both love talking about this stuff. So just, it will also send, our connection information. Just talk to us.
Great. And so then the last one, did you look at how on-call priorities change as companies become more mature? And yeah, I thought that was particularly interesting. So that for the companies that rated themselves as less mature, they started off by just focusing on how do we reduce the complexity of the environment. That one jumped up a lot more, and just how do we reduce the total number of incidents. And then as companies got more mature, they started to focus more and more on the customer experience. And so everybody was trying to reduce costs and things like that. But the more mature companies really started to look at what's the impact on the customer and prioritize their investments around that.
Yeah, I think, when you're first starting out, incidents are relatively rare, and everyone's willing to jump on them, and but as time progresses and your fleet grows and your company's more successful, now suddenly what you realize is that this is a fact of life, just as defects are. And what you need to do is improve your processes and your tooling to reduce your escape rate. Like, there's a measurement in software development around the defect escape rate from coding to QA to out in the field, and there's a cost associated with that. There's an inverse thing in incident management where you really want to reduce the number of incidents that each customer sees. And then, it's the reverse progression as it goes to support, or L1 to L2 to L3, in terms of the time it takes and the expense it takes to repair it in a very live environment. So the more things can be done quickly, the better off you are. It's kind of like mature people are thinking about fire safety, while immature people are thinking about firefighting.
Yeah, that makes a lot of sense. Yeah, another way that showed up in the data is that when we looked at what were the biggest causes of a major outage, for less mature people, they were much more likely to say, oh, it was some other service, third-party service that caused me to go down. Whereas the more mature companies, that number was half that. And so, it's a sign that those companies really thought about how do you build in redundancy and failover and things like that.
Yeah, and so I depended on a lot of other services when I was at AWS, and but eventually you have to agree that it's your own fault, right? And it's your obligation to be resilient to failures and other things. Like, there's a ongoing statement in the DevOps community that it's always DNS that's the problem. Well, you don't necessarily have to rely on a DNS lookup, right? Once you've gotten a DNS, that's something I did across all my services. Once you've resolved the host name to IP address, you can just cache the IP address. Now, that doesn't work if the IP address changes, or you had a failover or whatever, or you have a new host that you're managing. But it's a good way to resolve the common case of dealing with a DNS failure. It's basically converting an escalator, which when it breaks falls to the floor, to an escalator, an elevator, which when it falls to, which falls to the floor when it breaks, to an escalator, which turns into a staircase. Which one would you prefer, right?
Yeah, I always love it, that analogy. So it looks like that's the end of our questions for today. Hopefully you got a lot of value out of that. I know Anurag and I had a lot of fun talking about this, and we'll be sending out the recording, the slides, and the link to the actual survey results. And please don't hesitate to reach out to either one of us if you have further questions. Thank you so much.
Take care, bye.
Well, Anurag and Ashley, thank you both so much for joining us today. I really appreciate you guys sticking around to answer every question that came in. So thank you so much for jumping on and sharing your expertise with us.
Thank you.
Bye.
So I would love to remind our audience that this session was recorded. So following this panel, you'll receive an email with a link to access the recording on demand, or you can find it living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. So at the top of the hour, I promised we'd be giving away 4 $25 Amazon gift cards. So here are our winners. We have Matt V, David E, Laura M, and Andrew H. So to our 4 winners, congratulations. Keep an eye on your inbox to claim that gift card. But if you do not see an email, please monitor your spam folder. So to Shoreline, thank you.
Question asking for a link to Shoreline. So just go to the shoreline.io, and you can talk to us there.
Perfect. Shoreline.io. Thank you so much. And to Shoreline, we would really like to extend our gratitude for sponsoring today's program. And to our audience, thank you so much for joining us. We ask for 1 extra moment of your time to fill out a brief survey that will pop up as soon as we close out. But otherwise, we hope to see everyone at an upcoming Techstrong Learning program. Everyone, have a great rest of your day. And Anurag, Ashley, thank you so much.
Thank you. Bye-bye.